안녕하세요, 반갑습니다. 6월이면 어김없이 찾아오는 ICT 전시회인 컴퓨텍스가 시작되었습니다. 자, 컴퓨텍스가 시작되면서 엔비디아 그리고 AMD의 키노트 발표가 있었는데요. 이번 영상에서는 엔비디아 키노트 발표 주요 내용을 정리해서 전해드리도록 하겠습니다. 엔비디아 키노트를 실시간으로 시청한 분들 중 대부분 올해 공개할 것으로 예상되는 차세대 RTX 50 시리즈와 관련한 내용을 기다리셨을 거라고 생각됩니다. 하지만 이번 키노트에서는 소비자 시장의 지포스 라인업에 관련한 내용은 일체 언급되지 않았습니다. 최근 엔비디아 행보에 관심을 가지고 계신 분들이라면 아시겠지만 엔비디아의 핵심 사업 영역은 AI에 집중되어 있으며 AI 시장이 성장할수록 엔비디아의 입지는 더욱 탄탄해지는 구조로 흘러가고 있습니다. 자, 이를 증명하듯 2시간 가까이 진행된 키노트에서 엔비디아 젠슨함 회장은 AI 시장의 현 주소와 앞으로의 발전 가능성 그리고 산업 전반에 적용될 AI 기술의 미래에 대해서 강조하며 이야기를 풀어나갔습니다. 현재 엔비디아가 AI 시장을 리드하고 있는 점을 감안을 해볼 때 엔비디아는 AI 시장이 더 커지고 기술 발전 속도가 더 빨라지길 원하겠죠. 자, 먼저 엔비디아는 그동안 꾸준히 AI 시장을 준비해왔다는 걸 강조하면서 발표를 시작했습니다.
These domain-specific libraries are really the treasure of our company. We have 350 of them. These libraries is what it takes and what has made it possible for us to have such open so many markets. I'll show you some other examples today. Well, just last week, Google announced that they've put cuDF in the cloud and accelerate Pandas. Pandas is the most popular data science library in the world. Many of you in here probably already use Pandas. It's used by 10 million data scientists in the world. Downloaded 170 million times each month. It is the Excel, it is the spreadsheet of data scientists. Well, with just one click, you can now use Pandas in Colab, which is Google's cloud data centers platform, accelerated by cuDF. The speed up is really incredible. Let's take a look. That was a great demo, right? Didn't take long.
수년간 엔비디아는 AI를 강조를 해왔습니다. 재미있는 점은 메타버스라는 개념이 마치 신기술을 대표하는 단어처럼 어디에나 갖다 붙이며 사용되다 사라진 것과 다르게 엔비디아는 옴니버스 플랫폼을 기반으로 한 진정한 의미의 메타버스 환경을 구축, 여기에 디지털 트윈 개념을 도입하면서 공장의 생산 라인 시뮬레이션 및 기후 변화 예측 등 다양한 분야에 적용시키며 AI 기술을 적극 활용하고 있다는 겁니다. 물론 이 기술은 최근 몇 년간 엄청난 속도로 진화를 하고 있습니다. 또한 이번 발표에서 젠슨함 회장은 새로운 산업혁명이 도래했다며 AI는 커다란 변화가 될 것이며 그 핵심에 엔비디아가 있다고 거듭 강조했습니다.
It produces tokens. It's an AI factory. This AI factory is generating, creating, producing something of great value, a new commodity. In the late 1890s, Nikola Tesla invented an AC generator. We invented an AI generator. The AC generator generated electrons. NVIDIA's AI generator generates tokens. Both of these things have large market opportunities. It's completely fungible in almost every industry. And that's why it's a new industrial revolution.
최근 수년간 엔비디아의 발표 내용을 살펴보면 엔비디아가 강조했던 부분들이 AI의 중요 기술들로 등장하는 것을 볼 수가 있습니다. 어쩌면 그만큼 기술적으로 리드하고 있다고 해석할 수도 있겠죠. 그리고 최근 엔비디아가 큰 관심을 가지고 강조했던 부분은 바로 디지털 휴먼입니다.
Great to be in Taiwan. Before I head out to the night market, let's dive into some exciting frontiers of digital humans.
Imagine a future where computers interact with us just like humans can.
Hi, my name is Sophie, and I am a digital human brand ambassador for Unique.
This is the incredible reality of digital humans. Digital humans will revolutionize industries, from customer service to advertising and gaming. The possibilities for digital humans are endless.
Using the scans you took of your current kitchen with your phone,
They will be AI interior designers, helping generate beautiful, photorealistic suggestions and sourcing the materials and furniture.
we have generated several design options for you to choose from.
They'll also be AI customer service agents, making the interaction more engaging and personalized. or digital healthcare workers who will check on patients, providing timely, personalized care.
I did forget to mention to the doctor that I am allergic to penicillin. Is it still okay to take the medication?
The antibiotics you've been prescribed, ciprofloxacin and metronidazole, don't contain penicillin, so it's perfectly safe for you to take them.
And they'll even be AI brand ambassadors, setting the next marketing and advertising trends.
Hi, I'm Ima, Japan's first virtual model.
New breakthroughs in generative AI and computer graphics let digital humans see, understand, and interact with us in human-like ways.
From what I can see, it looks like you're in some kind of recording or production setup.
The foundation of digital humans are AI models built on multilingual speech recognition and synthesis, and LLMs that understand and generate conversation.
你们部落有什么特别的习俗吗？
我们有丰富的祭祀仪式和传统舞蹈，还有对大自然的崇拜。
The AIs connect to another generative AI to dynamically animate a lifelike 3D mesh of a face. And finally, AI models that reproduce lifelike appearances, enabling real-time path-traced subsurface scattering to simulate the way light penetrates the skin, scatters, and exits at various points, giving skin its soft and translucent appearance. Nvidia ACE is a suite of digital human technologies packaged as easy-to-deploy, fully optimized microservices or NIMs. Developers can integrate ACE NIMs into their existing frameworks, engines, and digital human experiences. Nemotron SLM and LLM NIMs to understand our intent and orchestrate other models. Riva Speech NIMs for interactive speech and translation. Audio to face and gesture NIMs for facial and body animation. And Omniverse RTX with DLSS for neural rendering of skin and hair. ACE NIMs run on Nvidia GDN, a global network of Nvidia accelerated infrastructure that delivers low latency digital human processing to over 100 regions.
최근 엔비디아를 보면 PC 소비자 및 게이머들에게 있어서 조금은 낯선 느낌도 들 수 있습니다. 소비자용 PC에 들어가는 엔비디아 지포스 그래픽 카드를 생산하는 기업보다도 AI 시장을 리드하고 있는 기업의 이미지가 더 강해졌기 때문이죠. 이를 의식했는지 이번 발표에서 젠슨 회장은 블랙웨일 제품을 공개하며 엔비디아가 AI용 GPU 중심의 기업이라는 점을 강조했습니다.
Ladies and gentlemen, this is Blackwell. Blackwell is in production. Incredible amounts of technology. This is our production board. This is the most complex, highest performance computer the world's ever made. This is the gray CPU. And these are, you could see each one of these Blackwell dies, two of them connected together. You see that? It is the largest die, the largest chip the world makes. And then we connect two of them together with a 10 terabyte per second link. Okay, and that makes the Blackwell computer. And the performance is incredible. Take a look at this. So, you see our the computational, the flops, the AI flops for each generation has increased by 1,000 times in 8 years. Moore's law in 8 years is something along the lines of, oh, I don't know, maybe 40, 60. And in the last 8 years, Moore's law has gone a lot less. And so just to compare, even Moore's law at its best of times compared to what Blackwell could do. So the amount of computations is incredible. And whenever we bring the computation high, the thing that happens is the cost goes down. And I'll show you. What we've done is we've increased, through its computational capability, the energy used to train a GPT-4 2 trillion parameter, 8 trillion tokens, the amount of energy that is used has gone down by 350 times. Well, Pascal would have taken 1,000 gigawatt hours. 1,000 gigawatt hours means that it would take a gigawatt data center. The world doesn't have a gigawatt data center, but if you had a gigawatt data center, it would take a month. If you had a 100 megawatt data center, it would take about a year. And so nobody would, of course, create such a thing, and that's the reason why these large language models, ChatGPT, wasn't possible only 8 years ago. By us driving down increasing the performance, the energy efficient, while keeping and improving energy efficiency along the way, we've now taken, with Blackwell, what used to be 1,000 gigawatt hours to 3, an incredible advance. 3 gigawatt hours, if it's a 10,000 GPUs, for example, it would only take 10,000 GPUs, I guess it would take a few days, 10 days or so. So the amount of advance in just 8 years is incredible. Well, this is for inference. This is for token generation. Our token generation performance has made it possible for us to drive the energy down by 45,000 times. 17,000 joules per token, that was Pascal. 17,000 joules is kind of like 2 light bulbs running for 2 days. It would take 2 light bulbs running for 2 days amounts of energy, 200 watts running for 2 days, to generate 1 token of GPT-4. It takes about 3 tokens to generate 1 word. And so the amount of energy used necessary for Pascal to generate GPT-4 and have a ChatGPT experience with you was practically impossible. But now we only use 0.4 joules per token, and we can generate tokens at incredible rates and very little energy. Okay, so Blackwell is just an enormous leap. Well, even so, it's not big enough. And so we have to build even larger machines. And so the way that we build it is called DGX. So this is our Blackwell chips, and it goes into DGX systems. That's why we should practice. So this is a DGX Blackwell. This is air-cooled, has 8 of these GPUs inside. Look at the size of the heat sinks on these GPUs. About 15 kilowatts, 15,000 watts, and completely air-cooled. This version supports x86, and it goes into the infrastructure that we've been shipping hoppers into. However, if you would like to have liquid cooling, we have a new system, and this new system is based on this board, and we call it MGX for modular. And this modular system, you won't be able to see this. Can they see this? Can you see this? You can? Are you? Okay. I say. And so this is the MGX system, and here's the 2 Blackwell boards. So this one node has 4 Blackwell chips. These 4 Blackwell chips, this is liquid cooled. 9 of them, 72 of these GPUs are then connected together with a new NVLink. This is NVLink switch 5th generation. And the NVLink switch is a technology miracle. This is the most advanced switch the world's ever made. The data rate is insane. And these switches connect every single one of these Blackwells to each other, so that we have one giant 72 GPU Blackwell. Well, the benefit of this is that in one domain, one GPU domain, this now looks like one GPU. This one GPU has 72 versus the last generation of 8, so we increased it by 9 times. The amount of bandwidth we've increased by 18 times. The AI flops we've increased by 45 times, and yet the amount of power is only 10 times. This is 100 kilowatts, and that is 10 kilowatts. And that's for one. Now, of course, well, you could always connect more of these together, and I'll show you how to do that in a second. But what's the miracle is this chip, this NVLink chip. People are starting to awaken to the importance of this NVLink chip as it connects all these different GPUs together, because the large language models are so large, it doesn't fit on just one GPU, it doesn't fit on just one node. It's going to take the entire rack of GPUs, like this new DGX that I was just standing next to hold a large language model that are tens of trillions of parameters large. NVLink switch in itself is a technology miracle. It's 50 billion transistors, 74 ports at 400 gigabits each, 4 links, cross-sectional bandwidth of 7.2 terabytes per second. But one of the important things is that it has mathematics inside the switch so that we can do reductions, which is really important in deep learning, right on the chip. And so this is what a DGX looks like now. And a lot of people ask us, they say, and there's this confusion about what NVIDIA does, and how is it possible that NVIDIA became so big building GPUs? And so there's an impression that this is what a GPU looks like. Now, this is a GPU. This is one of the most advanced GPUs in the world, but this is a gamer GPU. But you and I know that this is what a GPU looks like. This is one GPU. Ladies and gentlemen, DGX GPU.
최근 어떤 기사 및 커뮤니티에 등장하는 루머로 인해서 앞으로 엔비디아가 매년 새로운 그래픽 카드를 내놓을 것이라는 이야기가 있었습니다. 이번 발표에서는 안타깝지만 그 소문은 말 그대로 확인되지 않은 그냥 소문인 것으로 증명되었는데요. 엔비디아는 앞으로의 로드맵을 공개하며 AI 하드웨어가 회사의 주요 사업이며 핵심 프로젝트인 것을 거듭 강조했습니다. 그리고 블랙엘뿐만 아니라 블랙엘 울트라가 준비 중이며 이미 다음 세대 아키텍처로 루빈 플랫폼도 준비 중이고, 루빈이 출시되면 그 다음에 루빈 울트라까지 나올 것을 밝혔습니다. 이 모든 과정이 1년 주기로 이루어지며 이번 발표에서 공개한 로드맵상의 제품들은 심지어 모두 개발이 완료된 상태라고도 밝혔는데요. 그러니까 엔비디아의 1년 주기는 AI 제품군을 의미하는 거였습니다.
We're not stopping there. During the time of this incredible growth, we want to make sure that we continue to enhance performance, continue to drive down cost of training, cost of inference, and continue to scale out AI capabilities for every company to embrace. The further performance we drive up, the greater the cost decline. Hopper platform, of course, was the most successful data center processor probably in history. And this is just an incredible success story. However, Blackwell is here, and every single platform, as you'll notice, are several things. You got the CPU, you have the GPU, you have NVLink, you have the NIC, and you have the switch. The NVLink switch connects all of the GPUs together as large of a domain as we can, and whatever we can't do, we connect it with very large and very high-speed switches. Every single generation, as you'll see, is not just a GPU, but it's an entire platform. We build the entire platform. We integrate the entire platform into an AI factory supercomputer. However, then we disaggregate it and offer it to the world. And the reason for that is because all of you could create interesting and innovative configurations and all kinds of different styles and to fit different data centers and different customers and different places, some of it for edge, some of it for telco. And all of the different innovation are possible if we made the systems open and make it possible for you to innovate. And so we design it integrated, but we offer it to you disintegrated so that you could create modular systems. The Blackwell platform is here. Our company is on a 1-year rhythm. Our basic philosophy is very simple. 1, build the entire data center scale, disaggregate it, and sell it to you in parts on a 1-year rhythm. and we push everything to technology limits. Whatever TSMC process technology, will push it to the absolute limits. Whatever packaging technology, push it to the absolute limits. Whatever memory technology, push it to absolute limits. SerDes technology, optics technology, everything is pushed to the limit. Well, and then after that, do everything in such a way so that all of our software runs on this entire install base. Software inertia is the single most important thing in computers. When a computer is backwards compatible and it's architecturally compatible with all the software that has already been created, your ability to go to market is so much faster. And so the velocity is incredible when we can take advantage of the entire install base of software that has already been created. Well, Blackwell is here. Next year is Blackwell Ultra. Just as we had H100 and H200, you'll probably see some pretty exciting new generation from us for Blackwell Ultra. Again, pushed to the limits, and the next generation Spectrum switch, as I mentioned. Well, this is the very first time that this next click has been made. And I'm not sure yet whether I'm going to regret this or not. We have code names in our company, and we try to keep them very secret. Oftentimes, most of the employees don't even know. But our next generation platform is called Rubin. The Rubin platform, I'm not going to spend much time on it. I know what's going to happen. You're going to take pictures of it, and you're going to go look at the fine prints, and feel free to do that. So we have the Rubin platform, and 1 year later, we have the Rubin Ultra platform. All of these chips that I'm showing you here are all in full development, 100% of them. And the rhythm is 1 year at the limits of technology, all 100% architecturally compatible. So this is basically what NVIDIA is building, and all of the richness of software on top of it. So in a lot of ways, the last 12 years, from that moment of ImageNet and us realizing that the future of computing was going to radically change to today, is really exactly as I was holding up earlier, GeForce pre-2012 and NVIDIA today. The company has really transformed tremendously, and I want to thank all of our partners here for supporting us every step along the way. This is the NVIDIA Blackwell platform.
엔비디아는 이번 발표에서 AI 하드웨어 시장의 왕자의 위치에 있음을 한 번 더 확인시켜주는 것과 더불어 AI 산업의 방향성까지 리드하고 있는 것을 확인할 수가 있었습니다. 최대한 중요 내용과 장면을 정리해서 전해드렸지만 아마 여기까지 영상을 보셨다면 엔비디아가 확보한 입지와 기술력을 봤을 때 얼마나 대단한지 느끼셨을 겁니다. 2시간 가까운 결코 쉽지 않은 발표였음에도 불구하고 시종일관 여유 있는 모습과 꽉 채워나간 발표 내용만으로도 경쟁 기업들이 엔비디아를 견제하기가 정말 쉽지 않을 것 같다라는 생각이 듭니다. 마지막으로 5년 전인가 제가 웃자고 했던 이야기 중 이런 말이 있었습니다. 엔비디아가 어쩌면 현실판 스카이넷을 만들어낼지도 모른다. 하지만 스카이넷이 완성되려면 로봇이 필요하겠죠. 터미네이터가 나와야 되니까요. 영화에서는 스카이넷을 만들어낸 회사가 결국 AI 중심의 로봇까지 손댔던 기업이었으니까요.
About my size. And we have some friends to join us. So the future of robotics is here. The next wave of AI, and of course, you know, Taiwan builds computers with keyboards. You build computers for your pocket. You build computers for data centers in the cloud. In the future, you're going to build computers that walk, and computers that roll, around. And so these are all just computers. And as it turns out, the technology is very similar to the technology of building all of the other computers that you already built today. So this is going to be a really extraordinary journey for us. Well, I want to